this video, I'm going to demonstrate turn mill machining in EasyCam and designing in Alibre. First, we're going to activate a 2D sketch. Then we'll select our drawing plane. I'm going to use a connected line to define the general boundaries of our part. And in the corner, you'll notice there's a symbol, a constraint. That means these two lines will always be perpendicular to each other. I'm going to freehand the rest of our part. The sketch has to be closed when dealing with 3D models. Now I'm going to add dimensions where there are no dimensions. I'm going to generate an OD groove. Trim the center. Add a few fillets. Select the two lines we're going to fillet. Now we'll add a couple chamfers. Now we're ready to revolve a surface. Sketch 1, that's the first sketch we worked on. We're going to choose our axis. We're going to rotate around this line 360 degrees. Now for the flats for turn milling. I'm going to select the new plane. We're going to offset that by 1.562. We're going to activate the sketch, select plane 2. Now we're going to use a polygon, the center point, the number of sides, select our diameter, we no longer need that. Now we're going to offset our polygon so that we can create an extrude to cut the part. So we'll go to offset, figures to offset, and 1/2 inch is fine. We'll hit OK. deactivate our sketch. We'll use an extrude cut. We're going to go dual depth. That's going to be negative 0.5, 0.5. And that's completing our part at this stage. Okay, now that we've completed stage 1 of the project, let's import the file from Alibre. Now, if I look at the top view, you can see we're not in position to do any turning. So what I'm going to do is I'm going to reposition our coordinate system by using World UCS on Geometry. Then I'm only going to select surfaces and pick this front surface. Top view again, and we're ready to turn. I'm going to turn both sides. If you have a subspindle, great. If you're manually rotating the part, well, we can separate the programs as well. So you go to Curve, Silhouette Curve. That's going to rotate the model so that we can get the high points of this polygon. Alright. Now for turning, I don't need the solid model or geometry at this time, so I'm just going to blank them. We'll take our curve and generate its own geometry. Delete all links. It doesn't delete the curve, it just allows you to rebuild. So we're going to chain. We'll rough from here over to here. New turn. There is a library. You can pick tools from a library, create your own library, create your own tools, or you can just do things on the fly like I'm doing here. Under cycle data, I'm going to leave a finish allowance in both X and Z. The engage angle we'll say is 0. Pick our path. Verify. 3D preview. Now if you want to see the whole part, we can go to Automation, 3D Simulation, and Stock Curve. It's a cylinder. Our length is 3 inches. Our diameter is 3 inches. We'll move our subspindle coordinate, or the back side of the part. 3D preview again. My next step is maybe take a finished pass across the OD, maybe a finished pass on the front face. So if I was to do a profile, I can clean up that 10 thousandths that we left. And then what we do is we just go to path, select the same path, and verify again. I'm showing the tooltip. Now I'm going to hide that stock curve. Make another path. We're going to machine from this end over to this end. If I want to extend that, I can just go into the coordinates over here on the right, go another negative 0.1, and let's go a little further, a negative 0.5. Another profile pass. Now we're ready to machine the groove. Create another curve. We'll use arc move. We'll start here and work our way over there. We'll just borrow that tool. This will be tool 2, offset 2. The width, let's go with the 16th. And our radius is going to be 3125. I'll just copy that. And we're going to paste that right in here. That's just our program point. If you look at the graphics, we're actually calculating the G-code from the center of the tool. So if I touched off the tool, I skimmed it on the front face, we're going to move by the radius of the tool. Alright, let's take a look at what we get from there, our path, and verify. Step over value. Alright, we warn you when you do something wrong. Step over, let's make that 80%. Outstanding. So now let's show our model. I'm going to hide that for right now. We're going to work with our polygon. It's 8-sided. Now for here, we're going to go and make a face curve. Detect the open edges. You can see we get a little square over here. That just means that the tool can over travel in that region. Now we go to turn mill, curve milling. This will be tool number 3, offset 3. We'll use a 1/2 inch tool. The surface is the radius of the part, so that'd be 1.5. We'll wrap it over 1 inch. And we'll feed down from 100 thousandths. Depth will be 0 because we're going to use the curve for that. We're machining the side left, that's the main chuck, side right would be a subspindle. And we're using the world coordinate system. As you can see in red, that's the world. We will take and use high-speed machining. Our step over for a 1/2 inch tool, let's go with 1/8 of an inch. And that's going to need y-axis output. Pick our path and verify. I'll turn the tool off. If we preview, now we need to copy and rotate. Back into the work step. Copy options, start angle 0, increment angle of 45 degrees, and we have 8 of them. Verify again. Outstanding. Save my work at this point. And before we go into the back side, I'm going to make some adjustments in Alibre. We're going to add a couple of features to this part. So this is stage 3 of our video. We're going to activate a new sketch. Instead of picking a plane, I'm going to select the face. We're going to make a hole pattern. Snap to grid. Make a circular pattern from that. Select our object. Center point of rotation. Now we'll deactivate our sketch. Make a hole. Blind hole. The depth will be 0.5, diameter 2.5. Start surface. Select our holes. Okay, now we'll pick another face and we'll make a bore, which will also be another hole. This will be our start surface. The length will go 1 inch deep, 0.75 in diameter. Select our center. Okay, now we're ready to bring this into EasyCam. Now we're on the last stage of our project where we will machine the rest of the part. We don't have our bore and we are missing our hole pattern, so let's update the Alibre model. And we'll just do a quick verify. This is where we left off. Now we'll machine our bore. We'll pre-drill. Need a new curve. It's a 3/4 inch bore, so we'll go with a smaller tool. We'll go with 1 3/8 inches. Count for the drill tip angle. Turn off our constant surface feed. Select our path. Now we're getting into the bore, so let's cut the part in 3/4. Go to stock setup and 3/4 view. Verify again. Now for our path for the final bore. Start here and here. We'll use a rough bore to start. Change our stock curve to manual. Our inner diameter will say 0.6 for our drill size. Select our path. Verify. Now let's calculate. Let's go back in. 0.6. Verify again. We'll change over to our sub spindle. Everything we did on the main spindle is what we're going to do here. Change our coordinate system in the work step to sub spindle. Now our bolt circle. Select one hole and a second of the same diameter, and EasyCam will find them all. Curve drilling. This will be tool number 7. That's the distance from the subspindle 0 to the front face. We want the rapid higher than that value. And the depth of our holes is a 1/2 inch. We'll go a little bit beyond. This will be face right. Path curve ID will be number 9. And we'll do a preview. We'll tie it all together. And our part is complete. Thank you for watching.